Okay, now it's 5 Central European time, so our start time. So we'll get started. It's also 6 in Greece, 4 in Portugal, and a number of different times. There's some people joining from all over. So welcome everyone. Welcome to the Discovery Space Fall Webinar Series. I'm Michael Gregory from the European Physical Society, and I'm joined from a number of our partners, our Discovery Space partners from across Europe. I'll introduce them in just a second, but if you're just joining us and haven't yet said hi, please feel encouraged to say hi in the chat. Let us know where you're joining from. It's always exciting to see the variety of different places people are with us from. And sometimes it also helps us to adapt content slightly to where you're coming from. Often on the fly when we hear, it's not going to be personalized to all of your countries, but it is useful for us to know that as well, and good to hear from you. Just a couple of things about the webinars before I hand things over to our partners. So if you're new to this, well, this webinar series is new, but we had a Spring into Discovery Space webinar series also last fall, an AIMLO, Artificial Intelligence and Machine Learning workshop for teachers. Recordings from all of those are on playlists. I think you've received links. I'll add them to the chat in case anyone's interested and doesn't have them yet. This fall webinar series, the first couple of sessions will be fairly similar to the spring series. So we're starting with one from our partners at ICCS who have developed the online platform. They're explaining the theory behind Discovery Space and the platform, joined by Dimitris from EA, who will be presenting the full webinar next week, but he's been mainly, well, he's the main person in charge of the theory behind it. I don't know why it took me a second to think of the wording for that. But so it's great he's joining to explain that part of Discovery Space today. And I'll also briefly introduce Luisa from Nucleo, our partner in Portugal, who probably half of you, if not more, got the invitation from Nucleo, which is thanks to Luisa, and she'll be presenting both a Nucleo written scenario later on and some of the more in-depth things we're going to go into October. So I guess first I'll ask Luisa to say hi briefly before I turn over to the partners who are actually presenting today.
Hello, everyone. I'm Maria Luisa from Portugal, from Nucleo, and I'm really happy to join this series of webinars. And I think that we are going to have a really fun time discovering the Discovery Space platform and project. So I hope everyone enjoys.
Thank you, Luisa. And I guess, Dimitris, do you want to introduce yourself next
Yes.
before we go over to Evangelia and Nikos?
Sure, thank you, Michael. So, hello, my name is Dimitris Koulentianos. I work at the Research and Development Department of Ελληνογερμανική Αγωγή. Next week, I'm going to present the AI-assisted scenario for the simple pendulum, but today also I will give you a very brief introduction before Nikos goes into the technical details of the platform. So, welcome and thank you for being here.
And in case you haven't signed up for next week's webinar, I've just put the link into the chat as well. A lot of you I've seen have signed up for both already, which is great to see. But if you haven't, well, there's the link. And now let's hear from Evangelia and Nikos.
Hello, everyone. I'm Evangelia Nostopoulou from ICCS, and my colleague Nikos today will present the platform, the Discovery Space platform.
So, hello everybody, and thank you for being here. I'm Nikos Grammatikos from ICCS, and along with Evangelia and Dimitris Koulentianos from Ελληνογερμανική Αγωγή, we will be briefly displaying, presenting the theory behind inquiry-based learning and the whole technical part of the AI platform. So I don't know if I can go ahead and share my screen. I don't know, Michael, if...
Yeah, perfect. That would be great. Thank you.
Yeah. So I think you can see the screen, right?
Yes.
Yes, perfect.
All right. we will be presenting the inquiry-based learning and the Trust AI platform, an innovative system designed to support the inquiry-based STEM education through trustworthy artificial intelligence. And our goal here, with the whole idea of the Trust AI platform, is not to replace teachers, but to actually empower them, to give them the tools that help students to engage more deeply, think more critically, and learn more effectively. And at the same time, we're addressing the concerns around AI in education, like trust, transparency, fairness, and reliability. So I'm going to pass to give the floor to Dimitris.
Okay. So thank you, Nikos. Yes. As Nikos said, our goal here is to use AI, for the benefit of the teachers and of course for the benefit of the students. So what is our main goal? Our main goal is to develop an AI-assisted agent, an AI conversational agent, in order to measure students' problem-solving competence. Now, how to do that? First of all, we need to have some results. We need to identify some needs and we need to proceed from there. So that's why we start with this frame here. And if you see this frame, what it shows is the results from a measurement that took place from PISA. That's the PISA 2015 measurement about collaborative problem-solving competence. Now, since we are in Greece, you see that we have this red square, and as you can see, the results for Greece are very bad. So you see that we have these three different colors, and it's the red, the yellow, and the green. And as you can see in the first column, it's below level 1 and level 1. Then you have level 2, level 3, and level 4. For the purposes of this project, we identify these students being in this below level 1 and level 1 as low performers. Please keep in mind that the students are not aware of their, as they interact with the platform, they will never be aware if they are low, moderate, or high performers, and so on. The level 2 and level 3 now are the moderate performers, and level 4 are, of course, the high performers. And as I said, you can see that the results are very discouraging for Greece because for example, in the high performers, the OECD average is at 8%, and for Greece, this is only 2%. And then we have around 55% of moderate performers and 45% that are low performers. So action should be taken in order to change this situation somehow. So what is the first step towards that? Nikos, if we can move to the next frame. The very first encouraging results came from the Inspiring Science program, which was a project that ran a few years ago. And what happened there was to apply inquiry-based learning. So as you can see, instead of having the delivery of course content, to all the students in the same manner, we try to create certain phases for the teaching, for the subject that is being taught. So as you can see here, there are 4 different phases, which is of course the orientation and asking questions, hypothesis generation and design, then there is the planning and investigation, and at the end there is analysis and interpretation. At the end of each of these inquiry phases, there is an evaluation of the students, and then the students move forward. So the results that we took from around 8,000 students showed that, the situation for low performers was a bit better. So compared to the PISA results, around 33%. It was good also for moderate performers, around 40%. So there was a decrease, and there was a significant increase in high performers. So I remind you that in PISA we had around 2% for Greece, and here we saw something like 27%. So inquiry base is the first thing that we want to do, and we want to combine that with artificial intelligence, because I said here that, at the end of each phase, there was an evaluation of the student, and then the student was moving forward. This is sort of a summative assessment, but we want to apply formative assessment. And what do I mean about that? And I'm sure that you already know it, is that not only we check the level of the student, but we try to make an intervention and give him some help, some tailored feedback. So instead of having, as I said, the same for everyone, we try to, break the subject that we taught into these phases evaluate the students within the phase, and also provide help and guidance to the low and moderate performers so that they can become better and better as they progress through this inquiry-based cycle. And in the next frame, if we move forward, Nikos, I can show you why it's very important to have this AI conversational agent. So this is a traditional classroom model that I'm sure that you are all familiar with. So there is the teacher and there is a single learning path. So for example, if we have these three students shown here, you can see that one will be the high performer, the moderate performer, and the low performer. And what's the problem with this single learning path is that the low performer probably will find it very difficult, so eventually he or she will lose interest. The moderate performer will also, okay, say that this is ideal for me, and the high performer will probably find that very easy, and again we have the same problem, that these students will lose interest. Instead, what would be an ideal model, Nikos, if we can move forward, this is something like sort of a private tutor model, that there is a one-to-one correspondence. So there is one student, one teacher. So for student A, we have a teacher, the same for student B, the same for student C, and these teachers know exactly, all the points that the students face difficulties, what kind of help they need, what is the ideal educational content for them, and so on. Of course, imagine now a typical classroom with 25 students. It's impossible to have 25 teachers. It's something that, it cannot be applied in the real world. So here is where the AI comes to become the tool for the teacher. And what we want to achieve through Discovery Space is what you see here, that there is the teacher, there is an AI conversational agent, and with this conversational agent, the students will interact, and based on some initial instructions that the agent has received from the teachers and some, evaluation criteria and learning standards, questions, and so on, this AI conversational agent will draw a personalized learning path for each student. So we will have a personalized learning path for the low, the moderate, and the high. And the goal, of course, is to see that the students are progressing, that as they move through these inquiry cycles, they become better and better. Nikos, if we can move forward. Yes, and for the purposes now of our inquiry model, we have this picture here from Pedaste in a seminal work from Pedaste and co-workers. And because you see, before I said that we have this orientation and asking questions, but the names in the inquiry-based learning of the different inquiry cycles are not strictly defined. So as you will see within the platform, in the scenarios that we will discuss, we have this workflow model, that we have the engagement, the hypothesis, the experiment, the analysis, and the reflection. So in the engagement, we try to present a phenomenon to the students, and we give them some time, to observe the phenomenon, become familiar with it. Then we ask them to make some hypothesis to explain it. Then we go to the most crucial inquiry phase, the experiment, so that the students there are performing experiments to either validate or reject their hypothesis through analyzing the data that they collected. And finally, for some very, very strong students, we have the reflection. And here is the phase that only high performers will reach. And there we have some extra challenges for them. And the agent is also providing some extra challenges to the students. And if you see this workflow there, that with the 5 phases, you see that there is an exiting loop. So there is an evaluation in the phase, and if students, are in a level of low or moderate, they get into this loop and they get some targeted feedback from the AI agent before they move forward. And again, the students are not aware of their level, so each student is performing different tasks throughout the scenario. And so with that in mind, Nikos, can we move forward? Yes. What we want to achieve is to merge this traditional classroom that you see in the image on the top with an actual science lab that you see on the bottom. And as you can see in the middle, we have different students performing different tasks, and we try through that, to spark their interest, to foster their problem-solving skills, and so on. And for that, we have applied an inquiry-based learning with formative assessment through an AI-enhanced platform. And moving on, Nikos. Yes, and from now on, now we go to the details. So, Nikos.
Yeah, so thank you very much, Dimitri. We are now moving on to the actual platform. And here you can see the central piece of the project, the Trust AI Lab platform. It is a web-based environment where teachers can create and assign inquiry-based scenarios to their students. And students, as Dimitris said, interact with the AI agent, which guides them step by step inside the educational scenario. Now, based on the students' responses, it can follow different paths, offering their next relevant activity, skipping tasks, or providing additional support when needed. On the teacher side, the platform offers dashboard analytics, giving them insights into student performance. So this way, teachers don't lose oversight of what's happening. Instead, they gain an evidence-based understanding of where students succeed and where they struggle. Right now, the platform already hosts a wide variety of scenarios, 11 in total. Some examples are the pendulum, Galileo's observations, the photoelectric effect. An important aspect here is that these scenarios are available in multiple languages, such as English, Greek, and Portuguese. And this allows us to test the platform internationally and to adapt to it different classroom contexts. So each scenario isn't just a quiz, it's a structured learning path grounded in inquiry-based learning principles. Students go through the phases that Dimitris discussed earlier: the engagement, the hypothesis, the experiment, the analysis, and then the reflection, the 5 phases of the inquiry-based learning. Now, what exactly is a scenario? So think of it as a mini learning journey. Each scenario includes explanations, multiple answer questions, interactive experiments, and the AI agent acts as a companion, guiding students through this journey, through this process. So unlike static textbooks and worksheets, a scenario is dynamic. Students don't all follow the same path. If someone struggles, they receive additional support. If someone performs well, they are challenged with harder tasks. So this adaptivity is what makes the system important. It keeps students engaged while ensuring they're working at a level appropriate to their skills. Once you register in the platform, before beginning to work on your own scenarios and or copying another scenario, we're going to see this later, you must register or join an organization. So teachers are not just working alone. Schools and institutions can set up accounts, manage groups, and collaborate on scenario development. Within an organization, teachers can share scenarios, assign them to classes, and track performance collectively. And this makes the platform scalable beyond individual classrooms, supporting whole schools or networks of schools. This slide shows how student groups are managed. Teachers can create groups, and which is actually their classroom, and then assign one or more scenarios to this group. Before an implementation begins, the platform will automatically generate credentials for the students, so you don't have to create student accounts for each one of the students individually. These automated credentials can be downloaded in an Excel format. And we did this to make it easy to distribute the accounts without complicating things. So groups, as you are going to see, are flexible. Teachers, you can go back and add more scenarios to a group, or remove some scenarios from a group, or rebuilding everything from the scratch. So we try to keep this feature and this process as teacher friendly. Now, at the heart of the system is the AI learning companion. This digital companion supports students during the laboratory courses. It perceives and provides automated guidance and offers personalized recommendations. It does more than just answering questions. For instance, it will guide the student through a specific learning pathway, giving him or her more or harder tasks, and some feedback on the misconceptions. For teacher, it's like a co-pilot. It continuously gathers and collects data from the answers and the timing on students in order to assess the student performance. So this saves time and provides insights that would otherwise be impossible to gather at a large scale. Now, inside the scenario, you can also add some virtual and remote labs. On the left, you can see an example from Lapsland with a real pendulum experiment. Students can actually control the pendulum remotely, adjusting the parameters like length and mass and the angle of the release of the pendulum, and then collect the data from their own experiments by downloading a CSV to analyze the results directly. On the right-hand side, you can see a virtual simulation, in this case, a photoelectric effect. Here students can manipulate the light intensity, the voltage, and observe how electrons are emitted. So the integration of both physical and remote labs and virtual simulations allows you to give the students hands-on experiences even when the equipment is not available locally. On the same note, we are having some integrations with the VR and AR labs. So students can also interact with virtual reality or augmented reality. As you can see on the slide on the right, this is an image from a phone of a teacher that has set down the photoelectric effect, the experiment for the photoelectric effect. So a physics experiment can be conducted in a virtual lab, allowing students to manipulate variables and observe outcomes. So for schools without access to physical lab equipment, this is a game changer. Now, about the dashboard analytics, we're going to see this in further detail during the live demo we have at the end. So in general, the dashboard analytics are a crucial component of this platform and for you. Here you can see which learning path students are following more often, identify common bottlenecks in a scenario, or compare performances across different groups. Instead of relying only on end-of-term grades, so now you can have real-time insights on how students are progressing, which areas need reinforcement, and which students may need extra attention. And of course, you can also find errors in your own scenarios and balance the question and the subjects as well. Another thing in the dashboard analytics is the pathway identification. So the platform identifies common learning pathways. It highlights the routes students most frequently take through a scenario. So you can see patterns across different groups and help yourself understand not only individual performance, but also the overall effectiveness of a scenario. If, for example, many students are taking an unexpected route, that may indicate that the scenario needs to be revised, or that students are approaching the material in a different way than intended. Beyond pathways, the platform provides also student performance metrics. you can download CSV files with detailed data for each student ID in a student group. So these include indicators of problem-solving competence like timing, the score that the student achieved in a scenario, and the categorization into low, moderate, or high performance. So this feature allows teachers to adapt their teaching not just to the class as a whole, but to individual learners as well. To make the platform easier to use, we also have created a documentation page. This page acts like a tutorial hub for teachers and organizations. It explains how to create scenarios, manage groups, and interpret analytics. So we have the clear documentation and training materials for how to create scenarios and how to assign them to student groups and how to follow the analytics as well. Now we're going to the one of the core strengths of the platform, which is the ability of AI to recommend learning pathways. It doesn't just classify students into low, moderate, or high, as we discussed previously. It also looks at other patterns like how much time they spend on task, on a question or an experiment. So based on this data, the AI proposes changes to the learning path of a scenario. It might suggest that certain student categories skip activities, or that additional activities must be inserted for students who are struggling. The final decision is always left to you, to the teacher. You will review recommendations, ensure that the AI remains aligned with the pedagogical goals and doesn't override the human expertise in the classroom. So here you can see some examples of how AI interacts with learning pathways. For instance, here you see for the moderate performers, we have a new activity that has been generated. And the goal was here to strengthen the weak points without overwhelming the students. Again, here we see the opposite case. For high performers, the AI recommends skipping certain activities. This keeps high performers engaged and prevents frustration while still ensuring they meet the overall learning objectives. And sometimes the issue isn't about creating or skipping. It is actually about revising an activity. If the AI notices that many students are struggling with a specific question, perhaps because it's unclear or too complex, it will suggest modifications. And then you can rewrite the activity or clarify the wording or maybe adjust the difficulty level. So this makes scenarios progressively better over time based on real student performance data. An overview on how this works. So we have the data from a scenario. Oh, sorry. Here, yeah. So we have the data from the scenario. The AI analyzes student responses. Don't know why it does that. I'm so sorry. And highlights which parts of the scenario are working well and which part may need improvement. Teachers, then I'm just going to roll with it. Teachers are watching, are reviewing the recommendations, and they will either accept, reject, or edit a recommendation, as you can see on the screen right here, and then create a new scenario based on the recommendations that the AI did. Now, some of recommendation alignment we have already seen. So during the pilots, we found strong alignment. Teachers reported that students struggled with question 9 in one specific scenario, and the AI caught that and recommended changes into that question. And another example, I'm sorry, I don't know, it keeps bugging out on me. Can you see the screen? It keeps moving for you.
No.
It's going to thank you.
It's going to thank you, Nikos.
Okay, all right. Yeah, I'm not sure why it does that. So I'll just keep it brief. So teachers noticed many students struggle to interpret a graph question in one scenario, and then the AI recommended changes on that specific question, and they recommended changes on how to make the question more clear for the students. So yes, sorry for that, and I want to thank you for your attention for this presentation. In overall, the Trust AI platform is more than a digital tool. It's an approach to combine inquiry-based learning with trustworthy AI. It supports students in exploring scientific concepts and helps you to monitor and guide learning more effectively. So thank you, and we can now, if you have any questions, we can answer them now and then continue with the live demo of the platform.
So don't be shy if you have anything to ask. This is a good chance. We're here, well, and they're here to help you. So either in the chat, or if you feel more comfortable speaking, feel free to turn on your microphone if you have any questions for Nikos at this time, or for Dimitris.
All right, then shall I proceed to the demo? And if anyone has any questions, just feel free to interrupt me and just ask away. Don't know if that...
Sounds great. Thank you.
Perfect. Okay, so let me share my screen again. Sorry. All right. So I hope you can see the screen right now. Is visible, right?
Yeah, we can see it well. Yes,
Perfect,
with the
perfect.
platform, the dashboard.
All right, perfect. So this is the first page you are going to see once you log into the platform. This is the, let's say, the home page where you can see the analytics of your own scenarios or scenarios that you have made implementations on. Then the first thing we discussed about when logging into the platform is to create or join an organization. So up to the right, under your name, you're going to see the organization tab. And here you're going to see all the organizations currently listed in the platform. So maybe you will find an organization that your organization already exists. So you need to contact the admin of the organization in order to join. Or if you don't find your organization, you are going to create a new one. Ultimately, you'll have a screen like this, where you are going to have the country of the organization, the language, and a small description along with a picture. So why this is needed in the platform? In order to have groups of teachers working on scenarios collaboratively, and sharing ideas and applying those ideas on to the classroom by making the implementations on different scenarios. So once you have created your organization or joined one, you are going to the authoring tool. Right now, the authoring tool will consist of different scenarios, or you're going to see only the public ones, like here. So these public scenarios are the ones that are created by the partners of Discovery Space, and are used for making implementation in the classrooms. The ones that we can see, like the pendulum we discussed earlier, inside the scenario are the phases that Dimitris discussed earlier, and inside each phase, the activities. The activities that consist of a question, an explanation, and experiment. Down here is the activity chart of a scenario. This was made for the teachers to better visually understand the scenario. For example, after answering activity 1, there is an evaluation for the students. So for students who answered not correctly, so maybe answered 1 or 2 questions, took 1 or 2 answers that weren't correct, they went down this path. And for students that answered correctly, they went down the high performing path. So at first glance, you can see that in the same scenario, on the same learning journey, there are different learning paths for the different students in your own classroom. I'm going now to show you a small scenario that I usually show during demo. It's a very small scenario. It's just to show the different capabilities of the platform. There are 2 phases right now, phase alpha and phase beta, and inside the phases, if we're going to see the view, are the activities we discussed. So we start with an explanation, and there are again 2 questions. How to create an activity? Just go inside the phase and just press create activity. Just give it a name. Something to write. And then check what is the next activity. So I'm just going to press this. And voila, a new activity has appeared here. And if we go back to the demo AI, you can see it at the top in the updated activity chart. Here on the screen, again, we have the option to either view the activity we have created, update it, or just delete it. Updating it means we can change the name, the content, or even its type. I'm just going to create a new question activity. So when creating question activities, we need to add answers. So by adding an answer, we need to have a weight for that answer in order to score to progress the scores of the students. So an activity that is a question most of the times has 3 possible answers, with weights varying from 1, 2, and 3, with 3 being the correct answer. So, for example, here I can have a correct answer that is a weight of 3. I have answer 2 and answer 3. So the correct answer is always the one that has 3 weight. And you can see for both of the wrong answers, we have an answer weight of 1 and an answer weight of 2. What does this mean is that maybe an answer of a question is close to being correct, but it's not correct. So we are not just going to give it a 1, where it is almost correct, so we are going to give it a 2. So this is how we distinguish between high, low, and moderate performers. And I'm going to update the answers. And here, for example, you can see the question being here and the answers being on the right. I'm just going to delete these ones for now, like this. And go into the student groups. Here you can see my own groups that I have created for testing purposes. So I'm just going to create a new group. A user prefix is what is the first part of the username of the users. For example, maybe I need to put like something webinar 1. So every student account that will be made will be like webinar 1, 2, 3, 4, etc. So here is how to create a group. Give it a number of users and click on a scenario that I want, and then I'll get the credentials for that student group in order to run the pilot, to run the implementation. Now, once you have shared the credentials, the students will log in and land on this page, the student group. They will only see the scenarios that are have been assigned to their group. For example, the photoelectric effect. This is what the student sees. They will not see the restart button. This is only for teachers to see in order to test the scenario and go back to the beginning. An important thing is that the student cannot go back to previous questions, and their answers are locked in a way. So this is important to also share. So once they start the scenario, right now we have made some progress. I'm just going to restart to go from the beginning. Go start. So this is the introduction to the photoelectric effect. I'm going to read the introduction and have the first question along with its answers. So this is what the students see during one implementation. Once the implementation is done, you can see the analytics of a scenario implementation. Right now, I have selected the photoelectric effect that all the implementations that were made between 1st of August through today. So this is what we saw previously on the presentation. Here's the Sankey diagram where you can see the students moving to each phase, and high performing students becoming moderate into the second phase, and in the experiment going into low and high again. A final student performance for the whole scenario. An activity answer report only for the questions to see how many correct and incorrect answers were given into the questions of the scenario, and the average time spent in these activities. The performance overview, as we saw in the Sankey, on each phase. And one of the most important things we can see is the time spent in each phase by performer type. Maybe Dimitris wants to have some to give some insights for this specific graph.
Yes, just a short comment here. I mean, this specific diagram is something like a cross-check for your scenario, because I mean, here is not obvious because this is data recorded last month when we participated in the Balkan summer school due to the year of quantum mechanics. But usually what you expect to see here is that low and moderate performers, the red and the orange bars, consume most of the time in the initial phases of the scenario. So the engagement, the hypothesis, and around the experiment, you will see that moderate and high performers start to consume more time because, you know, there is not any more time available for the low and moderate performers, especially the low performers. And why is that? If you remember, I said that, you know, these students enter a loop, they get targeted feedback, and they start performing, you know, some activities while they are within this loop. So they spend the time there. Here, for example, you can see what I said in the reflection phase, that you see that the low performers have less time than the moderate, than the high. And in the pendulum scenario that we are going to discuss next week, that we had 500 implementations, you will see this image very clearly. So yes, thank you, Nikos.
Oh, thank you, Dimitri. And I think I have covered most of the features of the platform. I don't know if there are any questions or anything you would like to discuss, or
if I may have a short comment here, Nikos, I'm gonna put on the chat the Discovery Space link. Maybe Michael has shared it, the webpage already. So you can find all the tutorials and access to the platform through this webpage. Maybe this is something that you already know. I just shared it in the chat anyway for your convenience.
Oh, it's always good to have a reminder and to share links more often.
Maybe people could say if they have already been to the platform or not. Is it the first time, so that we understand if we have experienced teachers or not. If you can use the chat just to say if it's the first time that you're looking at it, or you have seen it. Not that you have to be an expert, but maybe you have already played a little bit, so that that might help understand the kind of questions that can be answered. So for Maria, that's the first. It's the first time. Bruno also. So you should have lots of questions, although it's a lot of information. Also first. So we have quite some participants that it's the first time that they are having a look at the platform. So if you were overwhelmed, you need to come back, because next time Dimitris is going to show step by step one of the scenarios. So I think this will complement what you have seen today.
I mean, in the meanwhile, I don't know, can I share, Michael, can I share my screen for a while to...
Yeah, please do, yeah.
So do you see the web page of Discovery Space? So,
yeah, it's coming through clear.
Okay, so if you come here to resources, you see that there is the Trust AI Lab platform that Nikos just gave this detailed presentation. And if you come down, here you can access directly the platform. And here you can find tutorials in Greek, okay, and we have, of course, one in English. So please feel free to visit the platform, get a profile there. There is a certain process that you need to follow in order to get the teacher account. You can find everything in the tutorial. If something is unclear, please contact either me or Nikos or Michael or Luisa. We are all here to help. And I think it will be very helpful. So it might look scary, but trust me, ICCS team has done a great work, and it's a really easy to use platform, and you can get very good statistics about your class. So I know that on the first time it might look a bit, out of the blue, but it's a really useful tool for all the teachers. Oh, thank you.
And one question I have along those lines, should we be encouraging them now to start creating teacher access accounts? And should we share the teacher access code with them? I haven't done that yet. Should we do that either in the chat or by email, or should that come later?
It's already in the tutorial, Michael, but if you want to share it also, this is very good, I think, since we have participants now here. And I think it will be very nice if until the next time, next week that we meet again, everyone has an account in the platform. It will be very helpful.
Perfect. So now just in the chat, there's the link to access the platform and the teacher access code when you first create an account. There's two parts of the page. I could share my screen for this, but it should probably be easy. There's login if you already have an account, or below that there's create an account. And that's where you'd enter what you want your username to be, and then your the teacher access code. And one thing we recommend to teachers, we recommend or advise, is to use your email address for your username, so that way you don't forget it. And if we're trying to figure out who's who on the platform, we can identify you that way. That's not a strict rule, but that helps both us and can help you in the future if it makes sense what your username is, rather than something where you might forget and we might not know who you are. And so I imagine probably there will be a lot more questions once teachers have started connecting to the platform, trying it out. Please feel very free to email us, contact us with questions. All of the future webinars will also be very happy to take any questions and feedback as you're connecting using it. So make a note of anything and ask us in whichever way you're more comfortable. And we're all here to help and to support you discovering Discovery Space. And that being said, if there are any questions already, even though this is a lot that's new, so it might be hard to figure out what you want to ask yet. Don't worry if you don't yet know what to ask, but if there are any questions, please let us know before we wrap up here.
Or maybe some comment on things that were a little bit more like a surprise for you. What do you think you can get from the platform? If you have any doubts of what the platform can give you, why should you use it? That kind of questions. It's also good to discuss.
And not surprisingly, it seems like people are a little bit shy. Maybe let's give it one more minute to see if anything comes up. In the meantime, I've just shared a link to register for next week's webinar, where Dimitris is going into detail on the AI-enhanced pendulum scenario. I've also included the link to the rest of the schedule. So far, on the schedule, we only have up until 2 weeks from now. But after that, Louise is going to be presenting the next one, which should be, I mean, we discussed, but didn't give it a title. It should be September 29th. But we'll get that on the schedule in about a week. So you'll have at least 2 weeks or so notice to sign up for that. Hopefully that'll interest you, and then we'll have the rest of the October schedule out relatively soon after that.
And for those that are not physics teachers, there are also scenarios on sciences and biology. Not so many, but they're coming along. And of course, you will be invited to create if you want. So although our first examples are physics, I think it's a bias we have because we have too many physicists working in the project, but still this is not restricted to physics. So all sciences are very welcome to have scenarios on their areas, their topics.
And on that note, it's also worth mentioning, because often there's some confusion. People see the name Discovery Space and they think that it's only about space science, but the idea of Discovery Space is it's a space for discovery. It's not just about space science, the scenarios that we have. It covers all topics of sciences. So I think we've given it enough time. It doesn't seem like there's going to be a lot of questions coming in. So I think we can wrap up there. First, I'd like to thank all the teachers who've joined us from so many different places. We hope this is just the start and that we'll see you back at our weekly webinars throughout the fall. And of course, a big thank you to all of the Discovery Space partners, Louisa for joining in, and of course, Dimitris, Nikos, and Evangelia for presenting today. So thank you, everyone.
Thank you.